Right, very good defensive mechanisms, but they don't work well enough with our bees. And can you explain what we do as beekeepers to complement the bees' own response? Like, how do beekeepers keep their bees alive with such a devastating organism lives on it? It's called Varroa destructor for a very good reason. It's a pretty bad critter.
Absolutely. Well, beekeepers try to control the mite by using miticides,
Right.
which are chemicals from synthetic or organic origin that are applied to the colonies in the hives and that kill mites. And most beekeepers do that, but there are some problems with using these chemicals.
And what would those problems be with using the chemicals? If they're effective at killing the mites, what could be a problem with that?
Well, there are a number of problems, but the two most relevant problems are that they might promote the development of resistance in the mites against the chemical ingredients in these medicines.
Mm-hmm.
So that happens with all sorts of pesticides.
Right.
Pests develop resistance against the pesticide. Bacteria, viruses, fungi develop resistance against antibiotics or antiviral medicines. And so that's nature.
Right.
The parasite is trying to defend itself from the damage that these chemicals cause in them. So for practical purposes, one miticide may kill perhaps 95-97% of the mites one year, and then the next year, but after 5 or 10 years it may be killing less than 50% of them because the mites have developed resistance. And the other problem is residues in hive products. When we medicate our bees, we're basically putting pesticides inside the hive. And honey and wax can be contaminated with those compounds if not used properly.
Right. It is a real challenge. Dr. Jim, too, from Ohio State, I thought put it pretty well. He said, we're trying to kill one bug that lives on another bug inside a box of food that people are going to eat. So we have to be very careful with what we're doing. Could you talk a bit about some of the other methods of controlling mites, natural chemicals, and what other options there may be?
Yeah, one option that we have tried also in our lab is testing natural compounds. For example, oregano oil, or thyme oil, the essential oil of thyme that we use in kitchens, in our cooking, clove oil.
So very safe, naturally occurring
Very
materials.
safe, natural occurring compounds. However, there are issues with them too. For example, we haven't found the right method of application, a good delivery system to make them work effectively in the hives.
Right.
And the same thing happens with the other option of biocontrol, using microorganisms like fungi to parasitize the mite and kill it.
Right.
And we haven't found a good method of delivery of fungi to kill mites, and they are also slightly toxic to the bees. And therefore, a third option to control the mites would be to breed bees that show more resistance to the mite than the average bees.
Right. So just kind of summing that up, then the synthetic pesticides are very effective, but resistance develops. There can be contamination issues. Natural chemicals can be effective, but their effectiveness is a bit more variable, and it still requires proper timing and that sort of thing. So the ultimate goal, basically, is breeding bees for resistance.
Well, the long-term goal will be to have resistant bees against the mite.
Right. So let's talk about this project then, and if you can give us an overview of our low varroa growth rate or LVG project, that would be great.
Yes, Paul. Well, we've been working on learning how these mechanisms of resistance work, like grooming behavior, like hygienic behavior, over the course of many years. But the specific project has three goals, three objectives. One is to develop populations of honeybees that show resistance to varroa growth rate.
Mm-hmm.
That is having several mechanisms functioning to prevent the population of mites to grow.
Right.
Objective number two is to test these techniques in the field and then transfer the methodology to queen breeders mainly, but to beekeepers in general.
Mm-hmm.
And the third objective of the project has to do with pinpointing genes at the cell level that contribute to these resistance given by LVG.
Right. So that would be looking for genetic markers that show that bees have those traits that we're looking for, right?
Yep.
So, and just kind of again summarizing, we're looking for the hygienic behavior, the grooming behavior, those kinds of social behaviors. At the end of the day, that amounts to less mites. So if we look for less mites, we're indirectly breeding for those social behaviors.
Not only that, we're also breeding for less viruses in the
Right.
bees. Because
Right.
if you reduce the population of mites, you also reduce the population of viruses.
Right.